Hi everyone, welcome to the series of the number system course. So in this lecture, we will do binary to decimal conversion. So if you haven't watched the previous video in this number system course, you can check it out through the link in the description box or by clicking to the I button. So what is binary number system? As I told earlier in the lecture 1 also, the binary number system contains only two digits, 0 and 1, and that is base 2 number system. And binary numbers are written as 1010 or 1101 or 10011 like this. And what is decimal number system? A decimal number system is the number system we use in our daily life. It contains digit from 0 to 9, and they are all base 10 number system. So what are the method of binary to decimal conversion? So to write, we have to write the power of 2 from the right to left. Okay, so like this, power of 2, and multiply each binary digit with its corresponding power of 2, and we shall add all the result. So let's take one example. So this I am writing a general formula over here. So this is the actually a general formula. You can remember like this also. What does this means? This mean a3 r cube plus a2 r square plus a1 into r to the power 1 plus a0 into r to the power 0 plus a minus 1 into r minus 1 plus a minus 2 into r minus 2. Okay, you probably didn't understood what I written. So let's take one example. So suppose we have binary digit 1010. Okay, and now we have to convert this to decimal. So what is the power of 2? Let's make a table like this. Here I am writing power of 2. Here I will calculate, and I will just put all the digit like this in a vertical manner. So power of 2 means 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So we'll consider this as a 0 index, this as a first index, this as a second index, and this as a third index. So this 3 will be as a power of 2. This 2 index will be as a power of 2. This 1 will be a power of 2, and this 0 will be a power of this. So what will be the calculation? This will be 8. This will be um, 0 into 4. So that means 0. This is 1 into 2. This is 2. 0 into 1. This is 0. And this is a 1. So this one has came over here. This 0 has came over here. This one has came over here. And this 0 over here. We shall multiply each binary digit with its corresponding power of 2. And then we will add all the result. So now if we add, we'll get 8 plus 0 plus 2 plus 0 equal to 10. So our answer has come. For the binary digit of the base 2, 1010 base 2, we got answer 10 base 10. This is our decimal number system. Okay. So let's take one example question. So we have to solve if we solve this kind of question daily, we'll get to know what is the beauty of this number system. So let's calculate. Let's uh, take this as a 0 index, 1 2 3 4, and this has minus 1 and this has minus 2. Okay, now a of 0 equal to 1, a of 1 equal to 0, a of 2 equal to 1, a of 3 equal to 0, a of 4 equal to 1, and a of minus 1 equal to 1, a of minus 2 equal to also 1. So how to calculate it? 1 to 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0 plus 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. So this becomes 16. This will become 0, 4. This will become 0 plus 1 plus half plus 1 by 4. So 21 plus 2 plus 1 by 4, we get like this. And this is base 10. Yeah, boom, we have converted this binary digit into human readable decimal number system. So binary to decimal conversion is the one of the most fundamental concept in computer science because it helps us to understand how computers store and process numerical data. So I hope you understood what is the how to convert binary to decimal number system. So we will now move on to